In 2026, a new workflow called vibe coding began trending. Users generate entire applications through natural language prompts rather than manual coding. The appeal is immediate. Instead of spending hours on manual setup, you can prompt a model for a full authentication system and receive hundreds of lines of functional boiler code in seconds.
Hey everyone, welcome back. Subscribe to AI Skills Learn for more awesome content. And don't forget to like and share this video.
But that initial speed often hits a wall. When a dependency updates or a user triggers a specific edge case, the system can produce an obscure error that brings the entire application to a halt. Scaling an AI-generated system without a deep understanding of its architecture makes debugging nearly impossible. Without a mental map of how the components connect, the user is left staring at thousands of lines of logic they didn't write. Relying strictly on these prompts doesn't confer the skills of a software engineer. It leaves the developer dependent on a machine's statistical best guess, which frequently fails when complexity increases. This dynamic isn't limited to hobbyists. AI coding assistants have been integrated into nearly every professional engineering environment, from startups to major enterprises. This chart shows 84% of developers now use AI tools daily. However, 66% are frustrated by code that is almost right but flawed. As a result, 46% of the community now expresses a lack of trust in AI-generated output. These almost right solutions are time-consuming. Hunting for a single logic hallucination in a block of generated code often takes longer than it would have taken to write the function manually. This creates a mandatory dilemma. Developers must use these tools to remain competitive in terms of speed, but they cannot trust the results without a rigorous manual review. The developer's job description has changed. Success in 2026 is less about your ability to write syntax and more about your ability to act as an architectural reviewer. In an industry capable of generating infinite code instantly, the primary bottleneck in software development has shifted from typing speed to human verification. To manage this trust gap, engineering teams are changing how they structure their codebases to defend against unpredictable AI logic. This has led to a requirement for strongly typed languages. A strongly typed language is one where the type of data, like a number or a string of text, must be explicitly defined, preventing the computer from making incorrect assumptions about how variables interact. This chart shows that strict type systems serve as an automated defense. By requiring explicit definitions, compilers catch AI-generated hallucinations before the code is ever executed. TypeScript, Java, and C# populate the high-safety, high-compatibility quadrant. These are the current enterprise standards for leveraging AI while maintaining system stability. This protection comes with a significant trade-off. Programming in these languages requires a steeper learning curve and forces developers to write more verbose, manual code to satisfy the type checker. But in loose, untyped environments, delegating complex logic to an AI can compromise long-term security. Without those rigid boundaries, a single generated error can propagate through the entire system unnoticed. Choosing a language in 2026 requires balancing performance and library support against the need for these automated safety nets. For teams relying on AI assistance, those boundaries are becoming a primary architectural requirement. While enterprise software leans toward type safety, there is a major exception to this trend in the world of data: Python. Python acts as the industrial engine for AI development. It is the primary tool for the high-level orchestration, packaging, and deployment of modern agentic systems. Python saw a 7-point jump in adoption over the last year. This is driven by its hosting of the industry standard libraries required for machine learning, such as NumPy and Pandas. Because Python prioritizes developer speed over execution speed, it is frequently paired with low-level languages like C++ or Rust to handle the heavy compute tasks required for model training. Python's partner in this environment is SQL, or Structured Query Language. SQL is a standard programming language specifically designed for managing and manipulating data held in relational databases. SQL requires set-based thinking, where you process entire groups of data at once. This is a critical skill for verifying how an AI retrieves and processes the massive datasets used to train models. While typed languages secure the application logic, Python and SQL manage the large-scale data ingestion and model orchestration that makes these systems useful. To navigate this landscape, developers must change how they structure their daily work to ensure they are getting a return on their AI investment without sacrificing quality. This chart shows the optimal 2026 workflow: a loop of human thinking, AI scaffolding, human verification, and automated testing. Productivity gains are highest when AI is restricted to scaffolding repetitive boilerplate. The core architecture must remain human-driven. For those beginning their careers, using AI to skip foundational concepts is a risk. It stunts the ability to recognize deep structural patterns, which is exactly the skill needed when the AI makes an error. Data and AI developers must master Python and SQL manually before introducing automation. Here, AI serves best as an explanatory tutor, not a primary generator. Web and enterprise developers should prioritize TypeScript. It provides the necessary baseline to defend full-stack applications against the logic errors common in generated code. The industry now demands a specific dynamic: the developer as the architect and the AI as the assistant. The most valuable skill in the 2026 job market isn't knowing how to write better prompts. It is the deep foundational expertise required to identify and fix exactly what the AI breaks.